Welcome back to the GCSE Maths Pro YouTube channel. In this video, we will be looking at the first part of iteration, where we'll just be going through the literal iterative process. So first of all, an explanation as to what iteration is. It's quite a niche or very specific topic within GCSE. I don't know, it feels kind of different to everything else that you've already done. But iteration does actually have a general meaning as well in the real world, not just in terms of maths, but in terms of general things. An iterative process can be any kind of process where you're trying to make small improvements every time. So I kind of like to use the example of, let's say that someone is developing an app. They're going to start with their basic rough idea, and then every time they work a little bit more on it, it's going to get closer and closer and closer to the final goal that they have, as in the finished app. Or even if you're doing some kind of coursework, every time you work on that coursework, you're getting a little bit closer, hopefully you're getting a little bit closer to the end result that you want to get, as in the completed product. So basically what we're saying here, in this particular context, we're using that type of process of keep making more trials, and every time you do move closer to your end goal. But in this context, the goal is to find solutions to an equation. So each time, you can see we've got 3 different values, but each of those values will get closer and closer to the actual true solution to the equation. It's basically a very specific way to solve equations, right? So often they will give you what is called an iterative formula. This bit here that kind of looks very confusing with all the x's and n's, n+1s, all of this. That can be quite confusing to interpret, but really it's very easy. You can also, if you want, think of it as like a sequence, but every time the sequence is getting closer to the end result. In this case, we're trying to find values that will get closer to the actual true solution. So each time they will become more accurate. It's kind of like a narrowing down process, I guess. You're trying to just get closer and closer to the most accurate solution at the end. So let's interpret what's here. The question says, using x n+1 is equal to -4 plus 5 over xn squared, with x0 being -3.5. Find the values of x1, x2, x3. Okay, that's probably just a load of random notation there. What this means is x is a solution, right? So we're trying to find what is x. But as I said, we're going to get multiple values because each time we're trying to get closer to the actual value of x. So we're going to make multiple attempts. x0, or I know with AQA, it's sometimes x1, or they might start with the 1. It'll either start with 0 or 1, right? They'll make it very clear. They'll say starting with. This is our starting value. So we're starting with -3.5. Imagine that's the first term in your sequence. I then want to find out the second term, the third term, and the fourth term, right? I've already got number 1. I'm then finding out 3 more terms. And it is often 3 times. They don't tend to do it more than 3 times. Sometimes it might even only just be twice. Now, what do we do with this formula, and what does that even mean? xn is just the current answer. So, for example, when we're starting, x0 would be there. And then it will create xn+1. That's effectively the next term in the sequence, isn't it? In order to find the next term in the sequence, or the next solution, you need to do -4 plus 5 over the previous term, or solution, squared. So what you will do is you will take your previous answer and sub it in. And then when you find x1, you'll take that as your previous answer and sub it in to find x2. And when you find x2, you'll take that answer and sub it in again to find x3. So it makes more sense when we actually demonstrate it. Let's actually show exactly what we're going to do. It's actually a very easy question once you've got kind of an idea of what we're talking about. So they've given us a starting point. In order to find, obviously we have to find x1 first. I need to do -4 plus 5 over the previous answer. So previous to x1 is x0, isn't it? So that's -3.5. But don't forget that this one is also squared. So that is what I will type into my calculator, and it will likely give you loads of decimals. Now, I've just put the brackets there because sometimes the calculators aren't really smart enough to know that when you square a negative number, it should become positive. So your calculator might be fine, it might square it correctly, but obviously technically it should square -3.5 and that should be a positive, which will affect our answer. So just double check that your calculator does square negatives properly. If you're unsure that it doesn't, you can also just not put the negative there because you know that you're going to square it, it will become positive either way. So ignore the fraction if there is an answer in a fraction, just convert it to decimals. Now, unless it tells you, I would probably write down at least 4 or 5 decimal places just so that you've got all of the figures there. So our answer, or our solution for x1, is negative 3.591836 ... You can see it's kind of similar to the starting value. It shouldn't be something completely different, right? It's kind of similar. Now, to find the value of x2, which is then the next term if you think about it as a sequence, I need to input, instead of negative 3.5, I now need to input the whole answer for x1. So not just the decimals you wrote down, but the whole answer, which is why it's often easier to use your answer button on the calculator. So we're going to do -4, still the same as before, plus 5 over, and instead of -3.5, it's now all of this squared, -3.591836 ... including all of the decimals. That's now our calculation. So what will be easier is if I just go back, and you can do this from the start as well, and I just put answer there instead. So when I press equals, it's copied all of my decimals. This is now the answer for x2. So we've got negative 3.6124. You can see the jump between x0 and x1 was quite big. The jump between x1 and x2 is now smaller. It's still progressing, but we're getting a little bit closer every time. We're kind of honing in or narrowing down onto that end goal, that actual accurate solution. So I'll put negative 3.61244, maybe just a few of those decimals, write them down. And then you just do the same for x3. Now, you don't have to write all of this working every time. What I would recommend is maybe write it down in the formula for the first answer, just so that they can see that you know what you're doing. And then once you've done x1, I'd probably just press equals with the answer button to get the next solution. So x3 is going to be the exact same again, but instead we're going to substitute in this answer. So every time you're taking your previous answer and substituting it into the equation where the x is. So if I now press equals once more, because I've put the answer button there, it's now going to copy the next answer. So I've now got for x3 negative 3.61685, obviously ... And so those would be my answers here. Negative 3.591836, negative 3.61244. And negative 3.61685. Definitely put a decent amount of decimal places down as well, because obviously if I rounded that to 1 decimal place, they'd all be the same solution, wouldn't they? You wouldn't be able to distinguish. So definitely write at least 3, maybe even 4 or 5 decimal places. If you want to write down every single decimal that you've seen on your calculator, that's also fine. But I would recommend using the answer button here, because even though you've got all of these digits here, the actual decimal might carry on. But because the calculator only shows a certain number of digits, it won't show you that it carries on, right? So don't just write down all of these digits and then type them in for the next go, because you'll still be missing some. So always make use of this ANS answer button, because it will copy, obviously not just the digits here, but technically the whole answer. So we want the most accurate answers as possible. So that's basically it. Hopefully that seems fairly straightforward now. You just substitute in your previous answer to get the next answer, and you do it 3 times. Now, we have the same question again here, it's just written differently. So, they've said here, starting with x0 being 1, so they've given us our starting point, use the iteration formula. So in this case, we've actually mentioned iteration. Sometimes they will, sometimes they won't, and you have to pick up that it is iteration. Using the iteration formula, xn plus 1, so the next term is equal to 5 over the previous term squared plus 6, 3 times, so again, often it is 3 times, to find an estimate for the solution of x cubed plus 6x minus 5 equals 0. So in this case, they've actually shown you the original equation that we are trying to solve. In the previous one, they didn't really show it to you. You could figure it out because the iteration formula is just a rearranged version, which is something we will check out in one of the other videos in my iteration series. It's just rearranged. You can see where the 5 has come from, you can see where the 6 has come from, things like that. Now, the other thing that's different about this one is they've said find an estimate for the solution, and there's only one answer line. So for this one, they want you to do it 3 times, yes, so that's x1, x2, x3, but they only want one final answer. So I'll show you which one you're going to pick. So I do exactly the same as the previous question, just set out x1 is equal to, write out your formula, so obviously now it's a different formula, and substitute in the previous answer. So the previous answer, or the starting point, is 1, isn't it? So 1 squared plus 6. That's what I will start with in my calculator. And I will show you a way to use the answer button so you don't have to keep typing it in. You don't have to do it this way if this is more complicated than the previous way that we did it, but what you can do is, whatever the starting value is, which in this case it's 1, just type that into your calculator, press equals, it's now the answer, isn't it? Then, over the top of that, just type in the formula, so 5 over, obviously where it says 1, you put answer, in this case squared, plus 6. So that's my whole formula, isn't it? If I press equals, obviously ignore the fraction again, we want decimals. I've now got my value for x1, 0.714285 ... Now, all you have to do once you've written that down is just press the equals button twice more to get x2 and x3. The only thing to be careful of is that you don't forget how many times you've pressed the equals button, isn't it? Make sure you do have the correct values for x1, x2, and x3. So that was 0.714285, a load of decimals. Okay, so for x2, I'm now not going to write out the formula again because they can understand that I know I need to substitute in values. And I'm just going to press equals again. So you can see I've now got a different number, a different answer, still quite similar, but a different answer, so 0.768025. And finally for x3, because we want to do it 3 times, equals again, 0.75874. And you can see that we've gone from 1 to 0.714 to 0.768 to 0.758. Each time we're narrowing down, we're getting closer and closer and closer. So the difference between the answers should reduce the more times you press equals. Obviously, you could press equals 1,000 times, but we're not actually going to do that. It's normally, as I said, just 2 or 3 times. The more times you go through the iterative process, so if you go to x10 or x15 or x100, the more accurate your answer is going to be. Now we have to choose which answer are we actually going to write down. In this case, when it says use it 3 times to find an estimate, because I said that the more times you do the process, the more accurate your answer is, we're going to put your final answer, so x3. This is the most accurate out of all 3 answers here. So again, unless they tell you how many decimals to put, just put at least 3, maybe 4 or 5. So for this one, we just had to choose the final solution that we got. Otherwise, it was exactly the same. The only difference with this third question is we now have a part A and a part B. So part A is pretty much the exact same as we've just been doing, but obviously with a different formula. So starting with x0 being 2.7, use the iteration formula xn plus 1 is equal to the cube root of 40 minus 8xn. Again, 3 times to find an estimate for the solution of x cubed plus 8x minus 40 is equal to 0. So just find x1, x2, x3. We can use the same calculator trick again, so put 2.7 into the calculator so that it saves it as the answer. Then on top of that, just write in the actual formula, so the cube root of 40 minus, and then we have 8 multiplied by the answer. So our value for x1 is 2.640012, 2.640012, ... x2, we then just press equals again, 2.66276, and finally x3, which we will use as our final answer because they've only asked for 1, 2.64181. So my final answer will be the 2.64181. And then for part B, we have, by substituting your answer to part A into x cubed plus 8x minus 40, comment on the accuracy of your estimate for the solution to x cubed plus 8x minus 40 equals 0. So literally just do that, substitute the answer. Now, not the answer that you can see kind of cut off the decimals for, but bring back your calculator. I want the whole answer here. I need to substitute that in to the equation. Now, obviously, because it's a solution, it is a value of x, isn't it? So I'm substituting it in where there is an x. So x cubed plus 8x, so 8 times by the answer, and then just minus 40. And there I've got this. Now, they've said that it should equal to 0. Your answer, what you're looking for, is the fact that you get something very close to 0. It won't be exactly 0 because we're getting close to the actual solution, but we're not quite there yet because you could do the iterative process loads of times, not just 3. But it should be something close to 0 if there is a 0 on the other side of the equation. I would probably show that you've substituted your answer in, then write the answer that you got, and now we need to comment on the accuracy of your estimate. We want to mention that it's fairly close to 0. So you could say something like accurate or fairly accurate as very close to 0. Obviously, if you got an answer of 5 or something, then that wouldn't be close to 0, would it? So it wouldn't be accurate. But the point is, you would most likely get something that is very close to 0. And our final question is again part A, very similar to the first question we had, to find the 3 solutions, and then a different part B that they could ask you in terms of worded questions. So using xn plus 1, which is equal to the cube root of 52 minus xn, so to get the next term in the sequence or in the solutions, you need to do the cube root of 52 minus the previous term or the previous solution. With x0 being 4, so that's our starting value, find the values of x1, x2 and x3. So this should be really easy by now. Just write it out for the first one, and then for the rest you can just put equals. Using our starting value, just put that as the answer, and then I can build my formula. So the cube root of 52 minus, and then obviously the answer button. So x1, my x1 solution is 3.63424. Then for x2 we press it again. 3.64344, quite similar numbers there. And finally, x3 would be 3.64321. So those are our 3 solutions. So that was all the same as we did before. The part B, though, is now saying to explain the relationship between the values of x1, x2 and x3 and the equation x cubed plus x minus 52 equals 0. Now we know that x1, x2 and x3 are solutions to an equation. If you have a look at this and compare it to your formula, you can see it's just a rearranged version, isn't it? We've got the 52, we've got just 1x, and we've got some kind of, this one's cubed, this is a cube root, so they've just rearranged it to create the iterative formula. So this is usually a 2-mark question. It's quite good because you can kind of just memorize the answer and just apply it to your particular question. So because it's 2 marks, we need to mention 2 things. One is literally that. What is the link between the equation here and the formula that we've used for iteration? Because they haven't really mentioned this equation in the previous part of the question, so we need to make that link. The link is that obviously the equation can be arranged to form the iterative formula. So that's point number 1. The equation can be rearranged to give the iterative formula, or some kind of version of that. Okay, how does the iterative formula then link to the values x1, x2, x3? We know that the process of iteration is used in this context to find an estimate for the solution to an equation, which in this case is this equation. So iteration is used to find an estimate for the solution of the equation. So some form of those 2 sentences. How does the equation link to the iterative formula, and how does the iterative formula link to x1, x2, x3? So that's a nice 2 marks for you there. So that pretty much covers the first part of the iteration topic, which is going through generally the process of iteration. Make sure that you check out the next 3 videos so that you have everything you need to know for the whole iteration topic. So thanks for watching this video. If you found it helpful, make sure to like and subscribe, and leave down below any questions or comments that you might have.